Today's lesson is on lesson number 3. Last class we talked about a direct variation and partial variation, and we know that direct variation, it always starts from the origin like this. This is direct. And for partial variation, we understand that it does not start at 0, 0, so it could start anywhere on the y-axis. So it could look like this, or it could look like this. Now, the coordinate geometry in 4 quadrants. Now, to describe the location of a point on a plane, we have to use a Cartesian coordinate system. So Cartesian coordinate system looks like this. I'm pretty sure you've seen this. So there are 4 coordinates here. Now for the first x-axis is the horizontal line. So it's a horizontal number line which extends from left to right. The y-axis, on the other hand, it's the vertical line which extends up and down. Okay? And the origin is a point where it's x and y is 0. And the order pair, a point of the form, is always in x, comma, y, in alphabetic order. X, y, it's located on a Cartesian plane. Now for x coordinate, it's the first number over here in an order pair, describing where the horizontal position is on the point. Okay. On the other hand, for y coordinate, it's the second number in an order pair, describing the vertical position of the point. Now, the quadrant, there are 4 regions created by x-axis and y-axis. So as you can see over here, we have 4 quadrants. Quadrant 1, 2, 3, and 4. We write it in Roman numerals. Okay. Now let's do an example of plotting the points below. So again, so we can label, this is quadrant 1, 2. So this section is quadrant 3 and quadrant 4. And you will notice that we have a horizontal x-axis and vertical y-axis. And over here, where the 2 lines meet, that is where 0, 0 is located. Okay. Let's start with letter A. A is located at 4, 3. So what that means is that the first point is x and the second point is y. So on the x-axis, I have to move 4 units to the right because this is in a positive direction. Also going up is positive, but if I were to go to the left, it's negative, and if I go down, it's also negative. So therefore, if it's 4, 3, I move 4 steps on x-axis, and then I go up 3 steps. So this is point A, 4, 3. What about letter B? Letter B, it looks like x, we're moving to the left by -5, and then we're going up by 1 step. So I'm going to go left 5 steps over here. This is -5, and then I'm going up 1 step. So this point is going to be letter B. What about letter C? I'm going down 2 for the x-axis and down 4 on the y-axis. So let's try. Always start with x first. So left 2 steps over here, -2. And then we're going down 4. So this is at -4 over here. So my point C is located here. And what about letter D? D is 0, 5. So I'm not moving any left or right step because x is 0, and I'm going up by 5 units. So this is 5 here. So this must be D. Now we're going to skip to letter H. So for letter H, you will notice that it's a fraction. So for the first x, it says 1 and 1.5. So fraction can be a little bit confusing. What you can do is just put it in a decimal. So this means 1.5, and y is -2. So I will be moving 1.5 to the right. So over here, right in between 1 and 2. And then I'm going down 2 steps. So it's right in the middle here. This will be point H. Okay. So let's take a look here. Now, which points are in quadrant 1 based on A, B, C, D, and H? So it looks like in quadrant 1, we have A, okay, based on what we have. And then for quadrant 2, we have B. And for quadrant 3, we have C. And quadrant 4, we have H. Okay. Now, if you take a look at point D is not in any of quadrant 2 or 1. It's right in the middle. Okay. So we cannot say it's in these quadrants because it's right on the axis. Okay. Now, describe which quadrant order pairs have the following signs. So if it's positive and positive, so we're going to the right and going up, so this must be in quadrant 1. If x value is positive, which we're going to the right, but the y value is negative, we're going down. So it must be in quadrant 4. If x is negative, we're going to the left, and we're going up, which is positive y, so it's quadrant 2. And lastly, if we're going left and down, which is both negative, must be in quadrant 3. Now let's take a look at lesson number 4. Now we are going to use a table of values to graph the linear relation. A reminder that a linear equation is always written in a slope y-intercept form. Y is equal to mx plus b, where m and b are always a number. So we're always looking for m, which is slope, and b, which is y-intercept. So number 1, it says determine if the following points are on the line y is equal to -3x plus 7. To double check if point A is on this line, what we can do is we can plug in the coordinates. 1 represents x and 4 represents y. So I will be plugging in 1, 4 into the equation. So instead of writing y, I will be writing 4. And for x, I will be replacing with 1. Therefore, 4 is equal to -3 plus 7. 4 is equal to 4. So as you can see, it is equal to, left side is equal to the right side. Therefore, we can say that point A, 1, 4, is on the line. Okay. What about point B? Same idea. What we're going to do, we are going to write down the equation, and we are going to plug in 0.2, 14 into the equation. So this is x and y. Y is 14, x is -2. So -3 times -2 is +6. So 6 plus 7, it gives me 13. So as you can see, 14 does not equal to 13. So left side, it does not equal to the right side. Therefore, point B, -2, 14, is not on the line. Okay. Now this time we will be looking at table of values. We are going to graph each relation by making a table of values with 5 entries. So you need to have a minimum of 3 to 5 points. Let's take a look at example 2a. So we are given y is equal to 2x. So first column is always x, and second column is y. Now just by looking at the equation, is it direct or partial? It's going to be direct variation. The reason why it's direct variation, because you don't have plus or minus a number here. There's no initial fee. We know that it's going to be starting at 0, 0 because it's in the y is equal to mx form. Let's plug in. So for x, I can plug in, let's do 3 points. -1, 0, and 1. And if I were to plug in y, I will be plugging in 2 times -1, which is -2. 2 times 0 is 0, and 2 times 1 is 2. What does this mean? I could translate this into a point coordinate. So it's -1, -2, 0, 0, and 1, 2. Let's plot the points. -1 is over here, -1, and this is 2. This is 1, 2. Unfortunately, the grid is a little bit wrong. Or what we could do is actually each square represents 1. So that means this is going to be 5 and 10, -5, 5, 10, and -10. This is -5 and -10. To graph the first point, we have -1, -2. So I'm going left -1 and going down 2. Next point we have 0, 0. And next point we have 1. We're moving 1 step and then going up 2 steps. And using your ruler, connect the points, and we have y is equal to 2x. So as you can see, it is a direct variation because it starts at 0, 0. It's passing through origin. Okay. Next, what about letter B? We have y is equal to -3x plus 4. Just by looking at it, we have like something plus a number. Therefore, it's going to be a partial variation. It's not going to pass 0, 0. Let's make a table of value x and y. -1, 0, and 1. -3 times, so instead of writing x, I'm going to plug in -1 plus 4. -3 times -1 is 3 plus 4, which is 7. And -3 times 0 plus 4 is 4. And -3 times 1 plus 4 is 1. Let's plot these 2 points. I'm going to use a different color this time. The points, if I want to write it in coordinate form, it's -1, 7, 0, 4, and 1, 1. So we have -1 all the way starting here. 0, 4, so at 0 it's 4, and 1, 1. Okay, so I can connect the points. So let's connect using a ruler. This graph is y is equal to -3x plus 4. Okay. Another way, so we just by looking at it, both of them are linear. Both. The reason why they are linear is because they are straight line. Both are linear because they're a straight line. Another way to look at it, what's the degree? Look at the exponent of the equation. Both of them are power of 1. The degree of the equation is 1. Or another way to check if it's linear is by looking at the first difference we learned from yesterday. The first difference is always based on the y value. So what we do is second number minus the first number. 0 minus -2 is 2. Next, 2 minus 0 is 2. So as you can see, the first difference is the same, 2, 2. Same thing here. The first difference, 4 minus 7 is -3. And 1 minus 4 is also -3. Therefore, the first difference is constant. It's the same. That's why I know that they are going to be a linear equation. But you must double check that the x values are also increasing at the same number, then it is linear. What did you have to do this time? Again, same thing, x and y. Look at the denominator. If you look at the denominator, it's 2. What you're going to do, your x value, you could do -1, 0, and 1, or to get a more clean number, you will be doing a multiple of 2. So therefore, I will be doing 0, -2, and 2. Therefore, when I plug it in into the equation, 1 over 2 times -2 minus 4, that will give me -5. 1 over 2 times 0 minus 4, that will give me -4. And 1 over 2 times 2 minus 4 will give me -3. So therefore, if I want to add more numbers, always do a multiple of my denominator. So you could do -4 and 4 and so forth. If you were to look at letter D, on the other hand, look at the denominator of my slope. My denominator is 3. Therefore, your points start from 0, and you're going to go up and down by multiple of 3. So it will be 0, 3, and then 3 times 2 is 6, so multiple of 3, -3, and then the next multiple of 3 is going to be -6. Therefore, you will get a clean number instead of using -1, 0, and 1. So watch out for that for multiple when you are given a fraction for the denominator. Okay. So try to put it in for C and D and find if you could find a point of intersection. Okay. But let's try example 3. So example 3 is a little bit different. So complete the following table of values and graph. As you can see, this is not a slope y-intercept form. Slope y-intercept form has to be y is equal to mx plus b. I want y to be alone. So what you can do is you could change it into slope y-intercept form, or you can just plug it in a point. So for example, as you can see, x is equal to 0. So to find y, for this one, I will be plugging 3x as 0 minus 4y is equal to 12. So 3 times 0 is 0 minus 4y equals 12. And I want to find y. So we're going to divide, 0 is just cancels out. So divide both sides by -4. It cancels out. Y is equal to -3. On the other hand, what about this one? So we will be plugging in -2 here. So 3 times -2 minus 4y equals 12. 3 times -2 is -6 minus 4y equals 12. I'm going to move -6 to the right by collecting like terms. So on my left side, -4y equals 12 plus 6. And then we're going to divide both sides by -4, whatever it's in front of y. Therefore, y is equal to, when you do it, you're going to get -4.5. So I'm going to try to write it in decimal so that it will be easier to see when I graph it. So -4.5. On the other hand, if we are given a y value, it's same thing. So for this one, I'm looking for x, 3x, minus 4. Instead of writing y, I will be plugging in 3 equals 12. And I'm going to move 12 to the other side, -12, by collecting like terms. So 3x equals 12 plus 12. And then x is equal to, divide both sides by 3, x is equal to 8. So therefore, this is 8. So you will do same thing for 6 and 0. When you plug it in, x is 6, you will get a y value of 1.5. And then for x value, when you plug in y as 0, you will get 4. Okay, so remember this is a not a slope y-intercept form, so you have to do a little bit of rearrangement in algebra. Let's plug in the points. So each unit, each square is going by 1, so 0 and -3. So I'm going down -3. This is at -3, 0, -3, -2, -4.5. So it's like right in the middle, in between 4 and 5. We have 8 and 3. So this is 5, 6, 7, 8. And then I'm going up 3, because this is 5. And then we have 6 at 1.5, so right in between the middle line. And we have 4, 0. Okay, so using your ruler, you will notice that it is perfectly a straight line. So this line is represented by 3x minus 4y equals 12. It's not very convenient to look at because it doesn't tell you the slope. But if I wanted to, you can rearrange this. We have 3x minus 4y equals 12. I want y to be alone. So I'm going to move 3x to the other side. So on the left side, I have -4y equals -3x plus 12, right? Positive 3x becomes negative. And whatever it's in front of y, we are going to divide by that number completely. -4, so it cancels out. Therefore, y is equal to negative becomes positive, so 3 over 4x minus 3. So this is my slope y-intercept form, and it's exactly the same as this line equation. And just by looking at it, what's my starting point here? My starting point is y-intercept is -b. And my slope is 3 over 4. Therefore, your starting point, which is at -3 here, and what you will be doing, I will be going up 3 and right 4. Let's double check. I'm going up 3, 1, 2, 3, and then I'm going right 4 steps. So 1, 2, 3, 4. And there you have it. Okay. So therefore, the standard form and the slope y-intercept form, these are the two same equation, but written in a different format.